Okay, example 3, find the number of seconds in a year. So that's part A, number of seconds in a year. So if we have 1 year, okay, well, let's see, I don't know how many seconds there are in a year, so I'm going to start breaking this down in units that I do know, in time units that I know. So how many days are in a year? Well, I know that there's 365 days in 1 year. Okay. How can I get to the, how many, what do I know about days? I know that there's 24 hours. 24 hours in 1 day. I want to cancel the day with a day. So in 1 day, there are 24 hours. All right. And then hours, I can get to minutes from there. In 1 hour, there are 60 minutes. Okay. And in 1 minute, there are 60 seconds. Now you may wonder how I knew whether to put seconds in the top and minutes in the denominator or vice versa. I knew because I'm trying to get to seconds. So I'm trying to get rid of minutes. I wanted to get rid of minutes, so I put it in the denominator. That started way over here. I wanted to convert from year to seconds. So I need to write year in the denominator, so these would cancel. I needed to write the day, so that would cancel. I need to write the hour, so these would cancel. I need to write the minutes in the denominator, so these would cancel. So the units will tell you if you've set these up correctly. Now I simply go across and I multiply the numerators together and the denominators together. 1 times 1 times 1 times 1 times 1 will be a 1. So when I multiply the numerators together and divide it by 1, I get 31,536,000 seconds. So what this tells me is that there's 31,536,000 seconds in 1 year. This is a conversion factor. And we will use this conversion factor for the next 2 parts of this problem. So sometimes you can create your own conversion factors, whatever's convenient that you need when you're doing work. Part B, it says, if one could count $1 per second, how many years would it take to count $1 billion or 10 to the ninth dollars? So for part B, if we have 10 to the ninth dollars, how long would it take to count this? All right. Well, if I have this many dollars, and it says right here, I can count, what does it say? If one could count $1 per second, let's multiply this by $1. It says we can count $1 per second. This is a conversion factor. Well, I want to get rid of the dollars, so I'm going to put the $1 down here and the 1 second up here. This is a 1. All right. All right. And so what they want to know is how many years would that take? Well, luckily I just did this conversion factor, which tells me there's this many seconds in a year. So since I want to kill the seconds, I'm going to write seconds down below. 31,536,000 seconds per 1 year. I will know if I set it up right by the units. Dollars cancels with dollars, seconds with seconds. So 10 to the ninth times 1 divided by 31,536,000 gives me 31.7 years. So this is how long it will take to count 1 billion dollars. All right. Part C. If one could count 1 molecule per second, the rate is 1 molecule per second, per 1 second. Okay. How many years would it take to count the molecules in a mole? Which there is, it's Avogadro's number, 6 times 10 to the 23 molecules in a mole. So we start with that. We've got to count 6 times 10 to the 23 molecules. And put it over 1 if you don't have anything to put it over. Okay, and we want to know how long it will take to count that many. And this is the rate that we count at, 1 molecule per second. Well, I want to kill molecules, so I'm going to put the second in the numerator and divide it by 1 molecule. Luckily, I have already come up with a conversion factor I'm going to use to convert it to years. I know that there are 31,536,000 seconds in 1 year. Have I set this up correctly? My units will let me know. Molecules cancels with molecules. Seconds cancels with seconds. I'm left with year. So when I take Avogadro's number and divide it by 31,536,000, I get 1.9 times 10 to the 16 years. Wow, that's a long time. That's how long it will take to count the number of molecules in a mole at this rate, 1 molecule per second. So that's a little bit of dimension analysis.